My dear students, so far we have seen in our previous videos introduction of vector product or cross product and their properties. Now in this video I am going to introduce geometrical interpretation of vector product. Already we have seen geometrical interpretation of dot product. Geometrical interpretation of dot product is nothing but the projection of vector A on vector B. A dot B is nothing but projection of vector A on B or projection of vector B on A. That is the geometrical interpretation. Now dot product. Now geometrical interpretation of cross product is we have to construct OA is vector A and OB is vector B. This OB is vector B. OA vector A and OB vector B. Complete the parallelogram OACB. Complete the parallelogram OACB. Complete the parallelogram OACB and draw BL perpendicular to OA. Draw BL perpendicular to OA. BL perpendicular to OA. And n cap is the unit vector perpendicular to the plane parallelogram OACB. N cap is the unit vector perpendicular to OA, A and B. N cap is the unit vector perpendicular to both A vector and B vector. And theta is the angle between the vectors A and B. Theta is the angle between the vectors A and B, OA and OB. Okay. Now, what is OA cross OB? By definition, OA cross OB, that is OA cross OB, that is A cross B, is nothing but OA cross OB. OA cross OB is mod of OA into modulus of vector OB into angle between A and B is sin theta, because it is a cross product. OA cross OB is mod of OA into mod of OB into sin theta into n cap. N cap is the unit vector perpendicular to both A and B. Now, what is modulus of OA cross OB? What is modulus of OA cross OB? That is again mod of OA is modulus of OA is modulus of OA and modulus of OB is again modulus of OB. Modulus of sin theta is sin theta and modulus of n cap is 1. Because modulus of OA cross OB is just get mod of OA into mod of OB into sin theta only. Because modulus of n cap is 1. Because modulus of n cap is 1. So you get only this is mod of OA. What is OB sin theta? Mod of OB is B sin theta. See, OA is A or OB sin theta. OB is B. From the triangle OBL, in the right angle triangle, right angled triangle OBL. In the right angle triangle OBL, sin theta equal to opposite by hypotenuse PL by OB. Sin theta equal to opposite BL by OB. OB is mod of OB, that is BL by OB is B. So BL equal to B sin theta or mod of OB sin theta. See, mod of OB is OB, right? You can write as OB itself. So this is BL is mod of OB in sin theta. You can treat as it is itself. Because OB sin theta, this is OA, mod of OA is OA, and OB sin theta is BL into BL. OB sin theta is BL. OA is, mod of OA is OA. So OA into BL, base into height of a parallelogram ACB. So OA into BL, BL is OB sin theta. So OA base BL is the height. So base into height is nothing but the vector area of the parallelogram OACB. So this is OA is base of the parallelogram OACB and BL is height. Therefore this is vector area, or otherwise you can write it as OA is base of the parallelogram into height. So base into height is vector area of the parallelogram. Vector area of the parallelogram OACB. So mod of OA cross mod of OB is vector area of the parallelogram OACB. This is nothing but mod of A cross B. OA cross OB is also, you can write it as mod of A cross B. So geometrical meaning of A cross B is modulus of A cross B is vector area of the parallelogram OACB. A cross B is, it's area of the parallelogram, not vector area, because modulus is area. Area of the parallelogram OACB. Suppose A cross B is vector area of the parallelogram. If just A cross B, if you remove the modulus, it gives you the vector area. Vector area of the parallelogram OACB. So geometrical meaning of A cross B is the vector area of the parallelogram having A vector and B vector as adjacent sides. That is the impression we get geometrically. So geometrical interpretation of cross product is nothing but the vector area of the parallelogram where OA as a base and B, A and B as the adjacent sides of the parallelogram. That's all. So we know the vector geometrical meaning of vector product is vector area of the parallelogram having A vector and B vector as adjacent sides. Suppose half of A cross B. You put a note, half of A cross B. That is equal to half of A cross B is OAB, vector area of the triangle OAB having A and B as adjacent sides. Okay, half of A cross B is vector area of a triangle. Vector area of a triangle OAB having A vector and B vector as adjacent sides. Adjacent sides of a triangle. Otherwise, this is also called half of mod of OA cross OB. This is vector area of a triangle. Vector area of a triangle having OA and OB as a vector area of a triangle having OA and OB as adjacent sides. Adjacent sides of a triangle. Okay, that's all. See, if you put modulus size, it is just area, not vector area. I already told you, if mod of A cross B is area of a triangle, area of a triangle OAB having A and B as adjacent sides. Similarly, half of OA from OB is area of a triangle, not vector area. If you are not mentioning by mod, then it is vector area. For example, you consider a triangle A, B, C. You consider this triangle. So area of the triangle ABC is of AB cross AC. From this you can get area of the triangle is mod of AB vector cross AC vector. AB cross AC vector of modulus value half of mod AB cross AC is area of a triangle having AB and AC as adjacent sides. Area of a triangle ABC having AB and AC as adjacent sides, whereas half of AB cross AC without modulus, if you get it without modulus, half of AB cross AC is vector area of triangle ABC. Vector area of triangle ABC. This is the difference. If you put modulus, that is area of the triangle ABC. If you are not mentioned within the modulus value, then half of A cross B and half of AB cross AC is vector area of triangle ABC having AB and AC as adjacent sides. Okay? Now we are going to prove sin of alpha plus beta, trigonometry result. Sin of alpha plus beta is equal to sin alpha into cos beta plus cos alpha into sin beta by vector method. Prove by vector method the trigonometric result sin alpha plus beta is equal to sin alpha cos beta plus cos alpha sin beta by vector method. For that you have to consider this diagram. OA is vector A. OA is vector A and OB is vector B or unit vectors. OA, OB are unit vectors, that is mod of A and mod of B are 1 because they are unit vectors. OA vector A and OB vector B. And OA and OB makes alpha and beta, angles alpha and beta with the positive direction of x-axis. OA and OB make angles alpha and beta with a positive direction of x-axis. Positive direction of x-axis. This is same as we derived in the case of sin cos alpha plus beta equal to cos alpha cos beta minus sin alpha sin beta. In the previous case of dot product, we have derived that result. Cos alpha plus beta equal to cos alpha cos beta minus sin alpha sin beta. Using the same diagram, we have derived that result in dot product. The same idea. This is alpha and beta with the OA and OB makes alpha and beta with the positive direction of x-axis angles. What is angle AOB? AOB is alpha plus beta. Angle AOB. This is alpha, this is beta, so AOB is alpha plus beta. You know OA vector equal to OL plus LM. LA, sorry, OL vector plus LA vector. By triangle law, OA vector equal to OL plus LA. OL plus LA. OL is the adjacent side of angle alpha. Therefore, OL is cos alpha into I vector because already we have derived in dot product. This is adjacent side of alpha, cos alpha into I, and LA is opposite side of alpha. This is plus sin alpha into J. This is OA. Similarly, OB vector. OB vector is OB is OM plus MB. OM vector plus MB vector. OM is adjacent side of angle beta. So cos beta into I vector acting in the direction of x-axis, and MB is opposite of angle beta, sin beta into minus j, because it is downward direction of j. So this is plus sin beta into minus j. Therefore I get cos beta into I minus sin beta into j. This is OB. Okay. Now OA cross OB by definition. OA cross OB, that is mod of OA into mod of OB into sine of angle between OA and OB. OA and OB, alpha plus beta. Okay. This is alpha plus beta. A cross B, OA cross OB is what is it? Mod of OA into mod of OB into sine of alpha plus beta in the direction, outward in the direction perpendicular to the unit vector both A and B is what is J. Okay. So mod of OA is 1, this is unit vector 1, so you will get sine alpha plus beta into J. So anti-clockwise direction, clockwise direction negative angle, and the direction of downward minus J, both negative will become positive. Therefore angle sine is negative, minus J is negative, double negative becomes positive. Therefore OA cross OB is sine alpha plus beta into J vector. This is your equation 1. Similarly, by determinant form, OA cross OB equal to determinant OA cross OB equal to determinant I, J, K. OA is cos alpha into I, this is cos alpha. J is plus sin alpha. Cos alpha plus sin alpha, K is 0, no K. Similarly, OB is cos beta minus sin beta, no K term, 0. So expanding this determinant, you will get I vector into 0, 0 minus J vector into 0, 0 plus K vector into what is that? Okay. This is alpha beta, OB is alpha plus beta. Oh, the light correction, C. One minute. Yeah, a small correction. This is A and this is B. Sorry. This is OB, B vector, and this is OA, A vector. So this angle is alpha. Right correction. Sorry. This is beta. Therefore you get alpha plus beta. OA, OB. OA is OM plus MA. OM. Just a correction. OA is OM plus MA. OM cos alpha into I, this is minus sin alpha into J. This is negative, therefore you get minus sin alpha into lambda direction minus J. So minus sin alpha into J. OB is OL plus LB. OL plus LB. Right. OL cos beta, right? Cos beta into I. This is also positive direction, sin beta into J. So this is cos beta into I plus sin beta into J. OA cross OB is A cross B, up clockwise direction, and unit vector perpendicular to both A and B is J. Therefore, this is say OA cross OB is mod OA into mod OB into sin alpha plus beta into J. This is sin alpha plus beta into J. This is equation 1. Okay, OA cross OB, similarly OA cross OB. It is also in the anti-clockwise direction. OA cross OB, I cos alpha minus sin alpha, and OB is cos beta plus sin beta. Cos alpha minus sin alpha, 0. Cos beta plus sin beta, 0. Now I vector into 0, 0. J vector into 0, 0. Plus K vector into cos alpha sin beta. Minus of minus plus sin alpha cos beta. Cos alpha sin beta minus of minus plus sin alpha cos beta. Sin alpha cos beta. So that is simply sin alpha cos beta, sin alpha cos beta plus cos alpha sin beta into K. So comparing equations 1 and 2, OA cross OB is sin alpha plus beta into J, K. K vector is the unit vector perpendicular to both I and J. Unit vector is perpendicular to both I and J is K. So n cap is K vector. So sin alpha plus beta into K. Similarly, sin alpha cos beta plus cos alpha sin beta into K. Equating 1 and 2, you will get the result. Equating 1 and 2, you will get sin alpha plus beta equal to sin alpha cos beta plus cos alpha sin beta. That's all about the etc. Okay, sin alpha plus beta equal to sin alpha cos beta plus cos alpha sin beta. Both are coefficients of K vector. Equation 1 and 2 are coefficients of K vector is equated. You will get the result. That's all about the trigonometric result, and I will derive the next result in my next video. Thank you.